Hello everyone, today I'm going to introduce the reinforced fine-tuning method. So OpenAI has recently announced that they will allow users to fine-tune O1 using this approach. The method with this name was proposed in a research paper from ByteDance about half a year ago. So today I'm going to introduce the method described in that paper. The method in this paper sounds slightly different, so it's called reinforced fine-tuning, but OpenAI refers to it as reinforcement fine-tuning. Though I believe, they are basically the similar approaches. Okay, here is the workflow. At the top, you can see the original model is trained on a dataset with chain of thought. So E is the chain of thought to the question X, and Y is the answer. This shows that if you train it for multiple rounds, the model becomes very robotic. However, if you train it for only a small number of epochs and then apply the second step, reinforced fine-tuning, you get better results than using only supervised fine-tuning. Okay, so let's get into the method. Here's the definition. Given a dataset, there is a question and a chain of thought represented as E. E is a sequence of actions, and each action is to generate a token, and each state consists of the tokens in the question plus the tokens generated so far. As we have seen, the first step is supervised fine-tuning, and given the dataset with the chain of thought, we train the model to produce the chain of thought. Then in the reinforcement learning phase, we need a reward function. For non-numerical answers, the action in non-terminal states are rewarded with 0, and the actions that lead to terminal states are rewarded with either 1 or 0, and if the answer is correct, then it's rewarded with 1. For numerical answers, since the answer can be closer or further from the correct value, so the actions leading to terminal states are rewarded on a scale from 0 to 0.1 to 1. As long as the answer can be extracted from the next state, then it receives at least 0.1, and if the answer is correct, it receives 1. So this encourages the model to produce a final answer rather than no answer at all. And then it's simply a matter of running PPO. So it's proximal policy optimization. We won't go too deep into that part. So you can read any paper or watch any video on PPO. And one thing to mention is that in this paper, the policy and value models share the same underlying LLM, but differ in their output layers. So the policy model uses the standard language modeling head, while the value model adds linear head to compute value estimates on hidden states. And now here are the experimental results. As you can see, they try to compare their approach with models trained with SFT and offline or online self-training methods. But those methods perform worse than the model trained with reinforced fine-tuning on multiple datasets. And the authors tried both natural language chain of thought and programming chain of thought. So those all work well, outperforming the method they compared against. That's all. Thank you for today.